Good evening, everyone. Welcome to this live session. So, after a long time, I'm live on this channel, and today we are going to revise our entire topic, units and measurements. I have covered this topic in great detail in Arjuna JEE in English in 10 sessions. Each session's like more than 1.5 an hour. In today's class, I'll be covering this whole topic in 3 hours. So now you may ask, sir, in 3 hours, what you will be covering? So in 3 hours, I'll be covering everything, by the way. Okay, we'll be going through each and every topic. Okay, yes, the speed will be a bit fast in few of the topics, and the number of questions will certainly be a bit less as compared to the great details which I have already provided. Now, so let us begin this discussion. Oh, you are from Arjuna JEE. Hello, welcome. So yes, I'll be covering the complete chapter. So let us start from the very beginning. What is physical quantity basically? How a physical quantity is defined? Now, any quantity which you can measure, okay, we call that as a physical quantity. That can be mass, that can be length, that can be force, time, temperature, intensity, anything, acceleration, velocity. Okay, all these are physical quantities. All are physical quantities which you can measure, which you can quantify. Okay, which you can quantify. If you can quantify something, that is a physical quantity. Okay, now so let us categorize physical quantities. Okay, so physical quantities can be categorized in two ways. First categorization is based on the directional properties. Like few physical quantities are scalar, few physical quantities are vectors. Xylem, yeah, I know about that. Xylem, Arjun. Sir, were you in Akash? Yes, I was there in Akash earlier, okay, before this. Now, first classification according to direction, okay, directional properties. So, few physical quantities, they have directional properties, okay, which we call them as vector. Few physical quantities, like the direction has no meaning in that, we call them as scalar. Okay, so according to this classification, okay, directional property, okay, classification according to, so first is like we have like one is the scalar, another one is the vector. Scalar is easy to understand, like they have the magnitude. Yes, they have the magnitude, but there is no meaning of direction in that. Like, you know, what is the direction of mass? What is the direction? No significant of direction. So mass is a scalar. Okay. What is the direction of length? Length is a scalar. Okay. Or temperature? Temperature is a scalar. So examples we can say here: length, mass, temperature, or speed, distance. Okay, like that there are so many examples of scalar quantities. Okay, now the next classification means two. Now first one is scalar, another one is vector. Okay, so second type, vector. Here we are having physical quantities. They will have magnitude, they will have direction. Okay, they will have magnitude, they will have direction, and they follow vector algebra, vector laws of addition, subtraction. They follow vector laws of addition, or you can say subtraction. If that thing is there, we will say physical quantity is vector. Like force. In force, you cannot just say 10 plus 10 is equals to 20. You have to see the direction. Okay, if a force is there, like let us take a block is there, you are applying a 10 Newton from this side. If I say apply 10 Newton more, and what will be the total force? You cannot say 20. It depends. If you are applying 10 from this side, okay, it will give you 0. If this is 10 and this is 10, then it will become 20. Total is 20 Newton in this case. If this is 10 and let us take this is 10, so that will be different. 10 root 2. Okay, so here whenever vector quantity is there, you cannot just add or subtract them without seeing the direction. That will be meaningless. Hello sir, I am Rishita from Arjuna JEE English. So glad to see you. Yeah, welcome Rishita. Good evening. Hello Chetan. Oh, hello Mokshit. So you have to see direction. Without a direction, if you just mention the magnitude of a vector quantity, okay, that is, you can say, half knowledge of that physical quantity. Okay, so here we have example. Which are the examples here? You may say velocity, yes. Displacement, yes. Force, acceleration, etc. There are so many other examples also, electric field, magnetic field, okay. They all are vector quantities whenever the direction is there. Now, second type of classification is based on their dependencies. Okay, so we define few of the physical quantity. Hello Hari. Oh, Ajwa. Oh, welcome Ajwa. So few of the physical quantities, we define them as the fundamental quantities, and then we say all the other physical quantity depend upon them. Okay, so that classification is according to the dependency. Okay, so if I say classification based on dependency, okay, so few of them we defined as fundamental, and how many of them are? Just 7. So 7 physical quantities, we call them as the fundamental physical quantities. Okay, all the other, doesn't matter what they are, all the other than these 7 fundamental quantities, we call all of them as derived physical quantities. PQ means physical quantities. Okay, 7 like these. How many number of derived physical quantities are there? Limitless. Okay, limitless, any number, it doesn't matter what it is. Okay, so they all are derived because they all depend upon these 7 fundamental quantities. Like if you say what is speed, I will say speed is distance by time. So speed is depending upon distance and time. Distance is the length, time is time. Okay, so I'll say the distance and time, they are that is my fundamental quantities, and the speed is depending upon them. Similarly, the acceleration, that is derived quantity. Similarly, the you can say force, that is the derived quantity. So just 7 quantities are fundamental. All other than 7, doesn't matter which they are, they all are derived quantities. Okay, they all are derived quantities. So these 7 we defined as the fundamental quantities. Okay, now first one is our mass, length, time, current, temperature, amount of substance, and luminous intensity. Other than these 7, all are derived quantities, means I can express any other physical quantity. That may be force, that may be acceleration, because force, acceleration is not there. That may be intensity, viscosity, terminal velocity, energy, or whatever it is. All depends upon these things. They are made up of these things. Okay, so therefore we call these 7 as our fundamental. Now, what is the symbol of that? For mass, we use kilogram as the unit. That is our SI unit, by the way. There are multiple like mass. For mass, you can measure that in grams, you can measure, okay, you can measure that in pounds. Okay, SI is our kg. So for mass we have kg, for length we have meter, for time we have second, for current Ampere. For temperature, we measure that in Kelvin, not in Celsius. For amount of substance, we have mole, and for luminescent intensity, we have candela. Okay, so all these are our fundamental quantities. Rest other are made up of these fundamental quantities. Those are derived quantity. Now, other than 7 fundamental, like these are my fundamental quantities. These are the units of the fundamental quantities. So I can say these are my fundamental units. Okay, fundamental quantities, units of them I called as the fundamental units. Okay, you may call them as the fundamental unit. Other than these fundamental units, we are having 2 supplementary units. One for the planar angle, another for the 3D angle. Planar means 2D angle. This is the 3D angle. So this is my 2D angle. This is the 3D angle. 2D angle, like the angle between the two lines in a plane. Okay, so let us take this as an arc. So whatever this angle is, that we call as, generally we denote that with theta. Okay, so that is my planar angle. What will be the unit of that? Radian. SI unit is radian. You may say, sir, we use degree also. Yes, we use degrees also, but degree is not the SI unit. Okay, degree is not the SI unit. The SI unit is radian, which we denote with rad. Okay, recently we learned circular motion. There we were using radian for theta, radian per second square for alpha, omega, like that. Okay, so how this theta is defined? This theta is equal to this arc length. Let us take this arc length to be S. So this theta is equal to S divided by the radius, which is R. So you take the ratio of the arc length and the radius, you will get this theta. Like for if you take that ratio for complete circle, what is my S? 2 pi R. What is my radius? R. That will become 2 pi, isn't it? The complete planar angle is 2 pi, we know that. So same thing. And the unit is radian, which we denote with rad. Now the solid angle, this solid angle is in 3D. This is not in 2D. Like you can consider, let us take this as a sphere. You consider some portion of the area there. Okay, how much angle that is subtending at the center? In 3D, that we call as my 3D angle. For this 3D angle, we denote with this symbol, this 3D angle, this symbol. This is omega. This is also a symbol of omega. Okay, so 3D angle we denote with this. What is the unit of that? That is steradian, SR. What is this steradian? If let us take this area which is subtending this solid angle at the center is S. So I will say this area S divided by the radius here is R. So S divided by R square. So that is equal to my solid angle. Now if you ask, sir, what is the total solid angle? Like for planar angle, how much was the total planar angle? 2 pi, one complete rotation. Similarly, how much is the total solid angle? How much is the total solid angle? So you can consider a sphere like this. Okay, how much total solid angle it is making at the center? What will be the area? Total surface area of the sphere, that is 4 pi R square divided by, what is the radius? R. So R square. So total solid angle is coming out to be 4 pi. Total solid angle. Hemisphere will subtend 2 pi solid angle at the center. Okay, and if some area is given, accordingly you can find, by putting in this, you can find how much solid angle it will subtend. Okay, so you used to teach in Akash. Yes, I was there in Akash. Now physical quantities have some units. Okay, now they may have multiple units, like for mass we have kg, we have gram, we have microgram, milligram. Okay, like that we have pound. So many units are there. Okay, for any physical quantity. I'm taking mass, you can take for temperature, we are having Kelvin, we are having Fahrenheit, we are having Celsius. Okay, for any other physical quantity, maybe force, we are having Newton, we are having Dyne, or let us take for energy. For energy, we are having calorie, we are having joules, we are having ergs. So there are so many physical so many units of a physical quantity. They may have 2 to 3 well known, but there are even more units of physical quantity. Now, how to choose a unit? Okay, like these are some characteristics of units. First thing is that should be well defined. You cannot say, oh, meter should be this much length. Then somebody asks you, okay, how much? Next time you will say meter is, I think, this much. Or somebody has defined its own unit of length. Okay, I used to measure length, so what I'll use is, I will use my own stick. Okay, that stick is having this length, accordingly I'll measure. I'll say the length of this wall is, let us take 5 sticks, like that I will define. But the convenience is not there. How you will define to other people so that they can understand? You are saying that is equal to 10 sticks, but the other person will understand, no, that is your own unit. Okay, so when you define a unit, that unit should be well defined. Like 1 meter is well defined, that is accurately a particular length. Okay, that is very accurate, very precise. Okay, then in variability, that there has to be consistency. Okay, it should not vary. Okay, sometime it is like this, sometime it is that much. Okay, it keeps on varying, then it is not a unit. Third is reproducibility. It means everybody should be able to use that. Okay, it's not that you defined your unit, you are able to use, but others are not able to understand how much is that. There is a confusion, so they cannot use that again. And yes, convenience to use, that's all. Now let us try to write, we know till now the units of our 7 fundamental quantities. Okay, we discussed for mass, length, time. Like, let us come back to that. This, so these are our 7 fundamental, okay, quantities. These are the 7 fundamental units of the quantities: mass, length, time, current, temperature, amount of substance, luminescent intensity. I got this. Now we are saying that any derived quantity will depend upon these 7 fundamental quantities. So the unit of any derived quantity should be expressed in terms of these 7 fundamental quantities. Okay, so any physical quantity, whichever it is, its unit should be expressed in terms of these 7 only. If you are not able to express that, then it means there has to be some more in it, in this list, otherwise that is not possible. Okay, but yes, these 7 include everything. So let us try to write the units of some of the fundamental, some of the derived quantities. So one by one, let us go. We have done this exercise, so we are doing this exercise again. So first of all, let us talk about velocity, or let us talk about speed. Simple. So whenever you have to write the unit of any derived quantity, first of all, try to write any of the formula. Sir, kaise samjhe? So what happened? Like, how's your father now? He's fine, Shiva. So Shiva, want to say anything? Yes, you can mention. I'll respond. I'll respond. Okay, so any quantity you like, this is derived quantity, I'm taking speed. So first of all, write the formula which you know. So I know speed is equal to distance divided by time. Distance divided by time. Now distance, what is the unit of distance? What is the unit of distance? Distance is a length. Okay, what is the unit of length? Meter. Meter per second. From that list, come back to that list. For length, meter. For time, second. So it is now meter per second. So this is how I can say that speed is my derived quantity. Okay, its units can be expressed in terms of the fundamental units. Similarly, I can take another example. You can take to be velocity. Okay, velocity, you may say displacement divided by time. The same way you can take acceleration. Okay, you learned that acceleration is equals to dv by dt, but let me write here as change in velocity divided by the time interval. For velocity, unit is meter per second. For time, it is second. So what it is now? This is meter per second square. I got the unit of the acceleration. Okay, so acceleration is a derived quantity. It is the unit of that. So third You may take force. Any formula for force, you know force is equal to mass into acceleration. Yeah, so I can say what is the unit of mass, that is kg. What is the unit of acceleration, meter per second square. So I got, and this is what we call as Newton. Okay, Newton is 1 kg meter per second square. Okay, then let us take another physical quantity. You may take pressure. Okay, pressure is, what is pressure? Pressure is force divided by area. Now force unit I already wrote. Okay, let us use that here, that is kg meter per second square. For area, meter square, so meter square. From here I got the unit to be kg per meter second square. So like that, any physical quantity, you should be able to write the unit of that physical quantity by writing the relation. Okay, some examples I took. Now, one physical quantity can have multiple units, I already mentioned. Okay, so simple thing, let us take, I'm having 10 kg. This is a mass. You can write this as 10,000 grams. Yes, you can write it like this, or you can write this as 10 into 10 to the power something. Okay, you can convert that to micro, you can convert that to milligram or like that. Okay, or you can convert to any other system of units also. So that way. Okay, so there are multiple. Can we convert one system of unit to another system of unit? Yes, we can convert. Here if you see, when I'm converting kg to gram, here this is my unit, this is the numerical part of that physical quantity. Okay, so this unit is getting smaller, kg is turning to gram, the numerical value is getting bigger. Unit is getting smaller, numerical value is getting bigger. So basically my physical quantity is having the numerical value and the unit, and this is basically constant. If you choose another system of unit where the unit is bigger, the numerical value will become smaller. If you choose another system of unit where the unit is smaller, the numerical value will become bigger. It's the opposite relation. So cover my class 11th with your one shot. Okay, yeah. Hello, Ikaf. Okay, so this is numerical value, this is the unit. If one will get smaller, another will increase. If one will get increase, another will get smaller. Okay, that way. Are you able to understand that? Okay, so this product will remain constant, because let us take the mass of a potato bag is having is 10 kg. Okay, now whether you express that in terms of gram, or you express that in terms of pound, or you express that in terms of another physical you can say unit, that 10 kg potatoes will remain the same, they will not change. Therefore we are saying this whole is a constant. Sorry. Now there are three well-known system of units: CGS, MKS, FPS. CGS stands for centimeter, gram, S stands for second. Okay, the first one represent the length, second one the mass, third one the time. Length, mass, time, only three are there. Yes, here only three are there in this. Okay, otherwise we know that there are 7 fundamental quantities. Okay, but in these systems we are having just the first 3: length, mass and time. MKS for length, what is that? That starts from M for length, meter, isn't it? Okay, then for mass, what is that which starts with K? Kilogram. Okay, kilogram. Okay, for time, what is that which starts from S? Second. Yeah, similarly FPS. Okay, what is the unit of sorry, what is the unit of my length that starts from F? Foot. Then what is the unit of mass that starts from P? Pound. And the time, it remains the second. So these three are well-known system of units, but yes, here we are having limitations. Here we are having only first three fundamental quantities. Now, in MKS system of unit, if I add another another 4, the remaining 4, the 7 will become complete. Okay, so let us add other 4. It becomes 7 complete, and that system we are calling as SI system of units. Okay, so in MKS system of unit, when you add the remaining 4, it becomes the set of complete 7. That set we are calling as the SI system of unit. So this is our SI system of unit. We have seen these 7. Sir is teaching in 0.5x. I should increase my speed? Don't worry, speed will automatically increase. Okay, we are starting the chapter, so I am taking time to, make the fundamentals. So don't worry about that speed. Speed will increase with the time. Simple thing, which of the following is a derived unit? Mass is a fundamental. Time is a fundamental. Current is a fundamental. Area is there. Area is meter square. The unit is meter square. So this is my derived physical quantity. Now here are one question, matrix match. Each physical quantity is mentioned, you have to match the units. Now it's not that in matrix match always they will give the SI units only. They may give, they may not give. You have to see, okay, here J stands for joule. Okay, in terms of joule they are giving the units. So accordingly you have to convert. For heat capacity, you have to see which formula you know that can relate heat capacity of the body, and then check which unit is matching with that. Accordingly you have to move. Now because you are starting your 11th journey, you may not be familiar with these you can say physical quantities which you will learn in thermodynamics. Okay, so let me help you with that. Heat capacity. Okay, so there is a relation that Q is equal to, okay, the heat given to the body is equal to heat capacity of the body into delta T. Q is the heat energy, C is the heat capacity of the body, delta T is the temperature. From there you can find, you can say C is equals to Q divided by delta T. Q is energy. What is the unit of energy? Joule. So joule. Delta T is change in temperature. What is that unit? Kelvin. So joule per Kelvin. So I got first as joule per Kelvin. So we are getting second from here. Then specific heat capacity of the body. Okay, we are having another formula for that. That is Q is equals to MS delta T, where S is my specific heat. Now you use this formula. I'm giving you the relation. So you may ask, sir, do we need to remember the relation? No, don't remember the relation. Just understand the concept. Anyways, when the chapter will come, you will remember that relation. So S is there. So S is equals to Q divided by M delta T. So it will become joule per kg Kelvin, like that. So joule per kg Kelvin, that is the third option. Then move to the fourth, latent heat. For latent heat we are having formula Q is equal to M into L, where L is the latent heat. So that is Q divided by M. Q is joule, the unit of M is kg, joule per kg. So joule per kg is my first one. And then here is our thermal conductivity. So for thermal conductivity, you have to use the formula power is equals to Ka delta T by delta X, where K is the thermal conductivity, P is the power, A is the area, delta T is change in temperature, delta X is change in length. Now you can use the these units and find what will be the unit of K. Okay, so you will get fourth from here. Second, third, first and fourth. Which one is matching here? Yeah, fourth option is matching. Okay, yeah. Similarly, there are some more physical quantities which you have to match the units, whose units you have to match here. Torque, you can use the formula tau is equals to R cross F. Okay, so R is meter, okay, F is kg meter per second square, okay. So I'll say meter into kg meter per second square. How I wrote like this? F is my force. Force is mass into acceleration. So this is mass, this is acceleration. So what is the unit finally? Kg meter square per second square, like that. So for torque, I am getting kg meter square per second square. Fourth one. Energy density. Energy density is energy per unit volume. What is energy? Energy is either you can use the kinetic energy formula, or you can use the potential energy formula. Okay, any of that you can use, and you can write the unit of that. Like if I write for kinetic energy, that is half mv square. What will be the unit? For mass it is kg. For velocity, meter per second. So meter per second square will be meter square per second square. I got the unit of the energy? Yes, I got. But it is energy density, means energy per unit volume. Divide that with volume also. So kg meter square per second square divided by volume unit is meter cube. So what I got from here, this is kg per meter second square. Kg per meter second square. First one I am getting. Okay. Like that, you have to see a relation, which relation you know, use that relation, then write the units accordingly. You will get the final unit of that particular physical quantity. Now pressure gradient is dp by dx, or you can write that as delta p by delta x, means change in pressure divided by the change in the distance. That is the meaning of pressure gradient. Now how we write for the pressure? Pressure is my force by area, and this is just length. You can write that as L. Clear? For force, what is the unit? That is kg meter per second square. How I got? Mass into acceleration divided by area, meter square, length, meter. That's all. This meter is getting cancelled. I got it as kg per meter square second square. Okay, so kg per meter square second square. That is the third one. And last is impulse. Impulse is force into time. Okay, this impulse is force into time. So what is the unit of force? Force is kg, mass into acceleration. So kg meter per second square into time into second. So this will become, this second will get cancelled. So this will become kg meter per second. Kg meter per second, second one. So we are getting 4132. 4, 1, 3 and 2. Yeah, fourth option is there. Okay, so whenever you have to write the physical quantity, you have to see the relation, then write the units of those relations, and then accordingly you'll get the final one. Okay, I hope Neha you got it. Okay, some questions here. Here E is there, H is there. These are 12th class concepts. You may see and you may get demotivated, sir. I don't know how to solve it. I'll tell you the relation. Okay, use those relation and then you can solve it, or you have to solve them after doing 12th class. But at least learn the concept. Don't learn the formulas. Okay, don't learn the formulas. Learning formulas is not at all required here, but you have to understand the concept. What is the process? How to take that process? Let us do this here. If E and H represent the intensity of electric field, okay, and magnetizing field respectively, then the unit of E by H is E by H. Let me tell you some formula for this. E is equal to potential divided by length. You can use this formula, potential divided by length. Then for H you can use this formula. Okay, that is current divided by length. You can use these two formulas and then you can put here and then find what is the unit of E by H. Potential by length, current by length. Divide them and then see what you will get. Try it from your side. Give it a try. Just you have to put it. Mm. So E is potential by length, H is current by length. Length are getting cancelled. You are getting potential by current. What is that? Potential by current. You remember some formula? V is equals to IR. V is equals to IR. So V by I is R. You are getting R from here. What is the unit of R? Resistance, ohm. You already know that, isn't it? So now, like if you don't know these relation, you may not be able to solve this question, but I don't want you to remember these relation. You have to understand like this way, this is the process to solve it. Anyways, you are going to learn these relations in your 12th class. Don't worry about that thing. Now, let us talk about dimensions. Now for every my fundamental unit, okay, I will define a dimension. When I will write the dimensional formula of any physical quantity, I can see how that physical quantity is depending upon the fundamental quantities. That is the purpose of that. Like here I am defining the 7 fundamental quantities are there. Yes, these are my 7 fundamental quantity. For each one I am defining dimension. For length, I will denote like this. For mass, this is the dimension. For time, capital T. For temperature, capital K. For electric current, A. For luminous intensity, candela, CD. For amount of substance, mole, like this. Now, if any physical quantity is there, you can write the dimensions of that particular physical quantity, and that dimension will give you understanding of how this physical quantity is depending upon the fundamentals. And yes, there are other applications also. We'll come to the other applications also in a while. Okay. Now, let us write the dimensions of some of the derived quantities. First, let us talk about velocity. Now, how we have to write the dimensional formula? First of all, write the unit. From unit, write the dimensional formula. So, velocity, what is the formula of velocity that you remember? Velocity is equal to displacement divided by time. This we know. What is the unit of displacement? Meter. Okay. What is the unit of time? Per second. I got the unit. This is my unit, meter per second. From unit, write the dimensional formula. For length, like meter denotes the length. For length, we have L. Yes. Per second. For second, we have time T. So T minus 1. These are my dimensions of velocity. I got the dimensional, sometimes we say dimensional formula of velocity, or sometimes we just say dimensions of velocity. It's the same thing. Then you may take next to be acceleration. So acceleration, you can write A as delta V divided by delta T. Delta V unit is meter per second, change in velocity only, divided by time, second. So I got the unit as meter per second square. Use this unit, write the dimensional formula for meter length, LT minus 2. LT minus 2. I got the dimensional formula. Okay, then let us take next as my force. Okay, so force, you can use the relation F is equal to ma. This formula I know. Write the unit. Mass is kg, acceleration is meter per second square. So I got the unit. Write the dimensional formula for kg, m. For this meter length, L. For second time, so mlt minus 2. This became the dimensional formula of the force. Like this, any physical quantity, first write that, the formula, write the units, write the dimensional formula. These are the steps. So I'm dropper. I covered physics 3 chapters, chemistry 3 chapter, maths 1. Can I achieve 99.2 percentile in January? Is it over expectation? I started in mid-July. So, but yes, you have to cover everything. Okay, you have covered till now these chapters, 3 in physics, 3 in chemistry, 1 in maths, but you have to cover everything. Okay, so try to cover everything first. Cover everything and do last 5 years PYQs very nicely, thoroughly. Okay, then you can get. Yes, Neha. Then the fourth one, let us take the pressure. We were taking their pressure. Okay, let us take pressure. Okay, let us take fifth one as momentum. So pressure is force divided by area. Then write the unit. Force is kg meter per second square divided by area is meter square. So I got the unit as kg per meter second square. From there I got the units as m L minus 1 T minus 2. ml minus 1 t minus 2. Then momentum we know that mass into velocity is the momentum. So momentum we denote with small p. Okay, so that is mass into the velocity. For mass we are having kg, for velocity it is meter per second. So the dimension formula will become for kg, that is m, then for this meter L, and then for time t minus 1, here t minus 1. I got it. In our batch, when we covered this chapter in great detail, like we covered all the like physical quantity that we generally talk about. Okay, so I took all the physical quantities of class 11th, all the physical quantities of class 12th, and we spent lot of time in deriving the formulas, the dimensional formula of the physical quantities. So if you want that complete list, so I request you can visit there. You may take few more. You can take maybe torque, moment of inertia, energy. Let's do at least few. I'll not be able to take the complete list. So for torque, I'll give the formula. Torque is equals to R cross F. Okay, or you can write that as just the magnitude RF sine theta. For R, that is meter. Okay, F is my force, so that is kg meter per second square. What will be the unit from here? Kg meter square per second square, same as that of energy. Okay, now if you write the dimensions from here, for kg m, L, for meter L2, for this per second square t minus 2. So m L2 t minus 2. We got it? Okay, moment of inertia, I, we denote a moment of inertia with I. So that is equal to m into r square. Use this formula, then write the units first. What is unit of mass? That is kg. R square, meter square. So kg meter square. That's all. Okay, from here you write the dimensional formula. For kg it will be m, for meter square L2. Okay, for energy, any type of energy, whether potential energy, kinetic energy, or maybe your electrostatic energy, okay, any other type of energy, doesn't matter, energy will have the unit of energy only. Now here if I write any formula for, let us write for potential energy. I know potential energy is equals to mgh, isn't it? M, mass, unit is kg. G is acceleration due to gravity, na? So meter per second square. H is, that's just the distance, the unit is meter. So I got kg meter square per second square. Okay, its dimension will become m L2 t minus 2. m L2 t minus 2. So this way you can write the dimensions of any physical quantity provided you know the relation. Now remembering the relations is not required. I don't encourage students to that, because anyhow when the chapter will come you will learn. Torque, if you don't know the formula, don't worry about that. When rotation will come you will remember that nicely. Okay, so just understand from here, this step you have to understand how you came from here to here, this step, and from here to here, that step. These two steps you have to understand. Let us do some questions now on this. The dimensional formula of latent heat is, I will give you the formula. From there you have to find the dimensional formula. So Q is equal to M into L, where L is the latent heat. So latent heat is equals to Q divided by M. What is Q? Q is my heat energy. What is M? M is my mass. Now you put here and then put the dimensions and then see which option is coming to be the correct. So Q is energy. What is the unit of energy? Unit of energy is kg meter square per second square. We just did, isn't it? So kg meter square per second square. This is the unit of energy divided by M is mass. So kg. So this and this are getting cancelled. So it is just meter square per second square. What will be the dimensions then? L2 T minus 2. L2 T minus 2. M is 0. L2 T minus 2. Third is coming. M is 0 there. Okay. Yeah, answer is third option. Now some more physical quantities are there: coefficient of viscosity, surface tension, angular momentum, rotational kinetic energy. Now first thing is rotational kinetic energy will have the same dimensions as that of energy that we did. That was ml to t minus 2. First option will come here. Okay, because it's the energy. Angular momentum, which formula you can use is L is equals to mvr. You can use this formula. For surface tension, force is equal to surface tension into the length. You can use this formula as I'm using for surface tension. For coefficient of viscosity, you can use formula a force is equals to 6 pi r eta into v, where eta is the coefficient of viscosity, r is the radius, v is velocity, 6 pi is my dimensionless constant here, and f is the force. Using these formulas, you can find the dimensions of that. Okay, so you can do this exercise from your side. After this class, you will get the notes. You can do this. So this is your homework. Linear momentum, we know the formula, mass into velocity. We did this. Frequency is just 1 upon time. So frequency is 1 upon time. Pressure is force by area. We just did that. Okay, so use these relations and then write the dimensional formulas. We just did them, so you can, and these also you can do from your side. So this also I'm leaving for you people as part of your homework. Okay, let us do these questions. These require some formulas of 12th class, and here those formulas are given to us. So let us go one by one with option A. So A, electric field. Okay, so the formula is given as this: force is equal to charge into electric field. Okay, so use that. Force is equal to charge into electric field. From there I can say electric field is equal to force by charge. Now force I can write. How to write charge? Charge is current into time. So force divided by current into time. Current into time. What is force? Force is mass into acceleration. Okay, so I can write that as kg meter square per second square, mass into acceleration, divided by I is current, so ampere, t is time, so second. That's all. Okay, then what will be the final units from here? Kg meter square per second cube ampere. I got this. Now write the dimensions. It will be m L2 T minus 3 A minus 1. These are the dimensions of electric field. Formula is given. Just find the units first, then find the dimensions of that. Now, yeah. So these questions which we are taking here, we have covered these questions in the batch. So I'm taking the same questions, okay, for your revision here. Next is my magnetic field. For magnetic field, this formula is given. You see, force is equal to Q V into B, charge velocity into the magnetic field. So I will use force is equal to charge BVQ. Okay, so from there I need what is the dimensions of which? Magnetic field, B. So B I'll write as force divided by velocity into charge. Now we can write the same way. What is force? What is the unit of force? Mass into acceleration. So kg meter per second square. Okay. Oh, I did sorry. Here I did mistake here. It should be meter per second square. Here also it's incorrect. Here also. Let me do it again here. So force, the unit is kg meter per second square, not kg meter square per second, that is for energy, divided by current is ampere second here for time. So what it is here, so kg, this is a meter, kg meter per ampere second cube, kg meter per ampere second cube, and if you write the dimensions, it will be m l a t minus 3, a minus 1 t minus 3. A is also in denominator, therefore a minus 1, and the second cube is there in the denominator, so t minus 3. For length, for m we are having L, for this kg we are having m, that way. Okay, oh sorry, you are Chetan, I forgot. Yeah, okay Chetan, yeah. Magnetic field is this, that way you write the unit of force divided by velocity is meter per second, and the charge is ampere into time. This is I into t, so ampere into time, that is second. Q I am writing as ampere into time, velocity meter per second. So here this is getting cancelled, this is getting cancelled, so I got this as kg per ampere second square. So it is m, and this is a minus 1 t minus 2, and accordingly you can write for other things also. All the formulas, once the formula is given, you can easily write that. Hello Kuldeep. Now, principle of homogeneity. Now this is an important principle which states that you can only add or subtract or equate those quantities which are having same dimensions. It means you cannot add a temperature with length. Can you add? What will be 30 degrees Celsius plus 10 meters? You cannot say 40. That will be meaningless. 30 degrees Celsius plus 10 meter. Will that make any sense? No. No. You will say it is not making any sense. It is incorrect. Okay. This cannot be done. It means physical quantities which are having same dimensions, only they can be added. Huh? So physical quantities having same dimensions, only them can be added, subtracted, equated or compared. Okay, these are all compare things. Okay, so you cannot add two quantities which are having different dimensions. You cannot subtract two quantities which are having different dimensions. But you can add two quantities which are having same dimension. Meter you can add with meter. Length you can, temperature you can add with temperature. Current you can add with current. That way you can do. So that is the principle of homogeneity. And few more things in that is, that you have to remember is, anything that is inside a log function. Let us take maybe x. Here x is my dimensionless. X is dimensionless. Dimensionless means the dimensions of x will be m0, l0, t0, like that we will say. Similarly, this whole function of log is also dimensionless. Same thing with the trigonometric function also. Trigonometric means sine, cos, tan, and these inverse of them. Okay, so if anything is there inside sine, maybe sine of kx, so this whole thing, this kx is dimensionless. This whole thing is dimensionless, and this entire sine function is also dimensionless. Something that is there in the power, let us take 2 to the power something x, this is also dimensionless. Okay, that is also dimensionless. So you have to understand these things. Some dimensionless constants like pi is there, that is a dimensionless. Okay, it is having certainly value, but the dimensions are not there. So these things you have to understand. Now let us use principle of homogeneity here. Electric field in a certain region is given like this. What is the SI unit of A and B? Okay, so here you see this plus equal to sign is there. It means dimensions on this side is same as dimensions of this side. Clear? This plus sign is also there. It means this physical quantity and this physical quantities, they are having same dimensions. These two are having same dimensions. It means these three are having same dimensions now. Dimensions of E is same as dimension of A by X square is same as dimension of A by Y square. Dimensions or unit, whatever it is, they are same. Now, I can say that electric field is dimensionally equal to A by X square. And electric field is dimensionally equal to B by Y cube. These three equal to signs which I'm using here, they are dimensionally equal, not equal, dimensionally equal. Okay, can I write what is the relation for A? A will be E into X square. Okay, similarly B will be E into Y cube. So I need just unit of A and B. Okay, what is the unit of electric field? We know the formula, na? Force is equal to electric field into charge. So from there I can say electric field is force by charge. Force unit is Newton, charge unit is Coulomb. They are using Newton and Coulomb, therefore I am writing in terms of Newton and Coulomb. Don't say, sir, why you are using Coulomb, why you are not using ampere? Because ampere is yes, that is the fundamental. Why not that? Why Coulomb? Because in the options I can see Coulomb is there. Therefore, I am writing that in terms of Coulomb. Okay, put the units here. Unit of E, Newton per Coulomb. X square, meter square. Similarly, E, Newton per Coulomb. Y cube, meter cube. I got the dimensions of both, the units of both. So that is Newton meter square per Coulomb and Newton meter cube per Coulomb. Clear? Yeah. Similarly, another question we are having here, this relation is given to us. What we have to find? That the dimensional formula of A by B. AB inverse means A by B. Okay, let us use the principle of homogeneity. So principle of homogeneity says, here is a minus sign, these two should have the same dimensions. So I will say velocity and B, they are dimensionally equal. Similarly, there is a plus sign, these two are having same dimensions. So I will say pressure and A by V square, they are dimensionally equal. Not equal in magnitude sense, only dimensions. Not in magnitude sense, so don't get confused. Only dimensionally I am saying. Okay, then I can say A is P into V square and my B is V. What I need? A by B. So A by B will be for A PV square divided by V. So that is P into V. And if you find the unit of P into V, that will be same as energy. You want to try it out? You can put P is pressure. Pressure is force by area. Volume is a length cube. Area is my length square, by the way. So it will just become force into length. So the unit from here, that will come out to be kg meter square per second square. If you have to find the dimensions, it will become ml2 t minus 2. Okay. Now, another example of principle of homogeneity. Here, let us first understand it. An expression of energy density is given like this. Here, U is my energy density. Energy density means energy divided by volume. Okay. Alpha, beta are constant. X is displacement. K is Boltzmann constant. T is temperature. The dimension of beta will be. So, first of all, here, see this. Here, this entire thing is dimensionless. Okay, no dimensions. Yes. Here this is a equal to sign. It means dimensions of energy density is same as alpha by beta. I need the dimensions of beta. So dimensions of beta is alpha divided by u. But I don't know the dimensions of alpha. I only know the dimensions of u. U is energy density per unit volume. That I know, but I don't know for alpha. Alpha, I have to use this. Here alpha is there. This is my alpha. Okay, this whole is dimensionless. Yes, and this is also dimensionless. The input of the sign, yes, that is also dimensionless. So this is also my dimensionless. If that is dimensionless, I can say alpha x divided by, I think there is, this should not be d, this should be k. There is some mistake here. K into t. K into t. Here the dimensions are m0, l0, t0. Okay, so I can say dimensions of alpha is same as kt divided by x. Okay, inverse, if you take this kt on the other side, same as kt divided by x. Okay, what is kt? Any formula? Yes, you can use this formula. PV is equal to nkt. You can remember, you will use this formula actually when you will learn thermodynamics. Okay, that is k into t. Then I can say n is just a number. I need the dimensions of kT, that is same as pressure into volume. So you can write this as pressure into volume by x. What was the unit of pressure into volume? Energy. Just we learned that. Okay, so here it is kg meter square per second square divided by, for x it is just meter. This is getting cancelled. So I got this as kg meter per second square. Unit of alpha, put it there, put the unit of u, you will get the unit of b. Okay, so let us do that now. From here, beta unit will be unit of alpha, that is kg meter per second square divided by unit of u, energy by volume. What is the unit of energy? Kg meter square per second square. Okay, divided by, for volume it is meter cube. This meter square is getting cancelled. So it is kg per meter second square. Kg per meter second square. Like this. Okay, so this is getting cancelled. This and this is getting cancelled. Okay, what we are getting, it is just 1 by meters. This 1 by meter will go in the numerator. It will just become meter square. So I'm getting m0 L2 T0. Fourth option is coming here. Okay. So that way you can solve this question also. Just apply the principle of homogeneity. Dimension of C is same as dimension of T. Okay. Dimension of V is same as AT square. Dimension of AT square, V, and these three things, they are same. That way you can solve, find the dimensions of A into B into C. So take this question as part of your homework. You can solve this from your side. Young's modulus, coefficient of viscosity, gravitational constant, and all these you can. I think there was one more question previously relating coefficient of viscosity. Yeah, previously we discussed that. So here I am just telling you the formulas. You use those formulas to write. For Young's modulus, Y is equals to, okay, force by area delta L by L. Change in length, delta L, length. Torque, you can use RF sine theta, we just did. Sine theta is dimensionless, by the way. For coefficient of viscosity, force is equals to 6 pi R eta into V. For gravitational constant, force is equals to G m1 m2 by r square, or you can say m square by r square. This you can use, and accordingly you can find the dimensions of that and you can match here. Okay, let me do for you for gravitational constant. Okay, so force is G m square by r square. From here, if you write the dimension, the relation for G, that will become F into R square by M square. This will, it will become. Okay. Now write the units. What is the unit of force? Force is kg meter per second square. Okay. R square is my meter square. divided by this. M is not meter, this is mass. Okay, so mass square, so that is kg square. This kg, this kg is getting cancelled. It is meter cube divided by second square kg. These are the units of G which I am getting. Now write the dimensions. Okay, m to the power minus 1, m to the power minus 1, L to the power 3, T to the power minus 2. These are the dimensions of gravitational constant. Okay, I'm JEE 2028 aspirant. Oh, welcome here. No, I'm not Tamil. I'm not Tamil. So this way you can find the dimensions of all the other and you can solve from your side. So this is also a part of your homework. Do it. I have told you the process to do. Let us do this question together. Here also we need to use the principle of homogeneity. Let us read it first. An expression for dimensionless quantity P. Okay, here P is dimensionless. They have given P is dimensionless. Is given by this, where alpha and beta are constants, X is distance, K is Boltzmann constant, T is temperature, then the dimension of alpha will be. Okay, P is dimensionless. This whole is also dimensionless, isn't it? This is dimensionless. This is also dimensionless. Okay. It means alpha by beta is dimensionless. It is dimensionless. It means dimensions of alpha and dimensions of beta are same. That is the meaning. So find the dimensions of beta. That will be the dimensions of alpha. So basically I need to find the dimensions of beta. Okay. I know that the input of log function is also dimensionless. This is also dimensionless. Okay, if that is also dimensionless, I can write kt by beta into x. This is also dimensionless. Okay, then what I need beta. So beta dimensions will be kt divided by x. Now kt, previously also I told na, kt is same as p into v, the unit, pressure into volume divided by x. Now you put the units here. You put the units here. What is the unit of pressure into volume? That is same as energy. So that is kg meter square per second square divided by x meter. Got cancelled. So this is kg meter per second square. Kg, sorry, just a minute. Kg meter per second square. Now check the dimensions. MLT minus 2. Third option is matching. Kg meter per second square. Okay, clear? I hope you are able to understand this now. Dimensions of 1 by mu naught into epsilon naught. Mu naught is permeability of space. Epsilon naught is permittivity of free space. Now you don't know this relation, and yes, you cannot solve if you don't know the relation, but I will tell you the formula, okay, that you will learn in 12th class. So speed of light is equal to 1 by root of mu naught into epsilon naught. Now use this relation to find the dimensions. I told you the relation. Now you should be able to write the dimensions. We have done so many questions now. So give it a try from your side and tell if you are able to get it or not. But you have to tell in terms of that. Yes. Crazy gamer. Very good. You are able to understand, but tell in terms of L and T. Okay. Option, yeah, yes, you are correct. So from here, if I write 1 by mu naught epsilon naught, okay. So this is my speed of light that I represent with c, okay. So 1 by mu naught epsilon naught will be my c square. What is the unit of c? Speed, na? Meter per second. Meter per second. So if you do the square, it will become meter square per second square. Meter square per second square. What will be the dimensions of this? L2 t minus 2. Okay, L2 t minus 2. L2 where it is, t minus 2 third. Yes, okay. So that way, easy. Next. Okay, now let us talk about dimensional analysis. Till now we have learned how to write dimensions of any formulas. Now we will learn what is the use of those dimensions. Till now I was just talking how to write dimension of this, how to write dimension of that. Now you will say, sir, what is the use of that? So these are the 3 applications of dimensional analysis. First one, checking consistency. You can tell whether an equation is correct or wrong, means correct or incorrect dimensionally, okay, by dimensional analysis. Let us read this question. E represent energy, P represent momentum of a body of mass m, okay. These are the equations that relates. Given that C represent the speed of light, identify the correct equation. Now you have to see which relation is correct from here, that you have to check. Now you will say, sir, how to check? Apply principle of homogeneity. Apply principle of homogeneity. If principle of homogeneity is being applied here, I will say that is dimensionally correct, okay. Dimensionally correct, otherwise that will be incorrect. So here equal to sign is there, it means dimension of this physical quantity should be equal to the dimension on the right side. Here this is plus sign, means dimension of this physical quantity is same as dimension of this. Now you check, are these 3 quantities having same dimensions or not? Are these 3 having same dimensions or not? If they are having same dimension, it will be correct. If they are not having same dimensions, that will not be correct. Okay, so this is what you have to do. So go one by one from the first option and check which are having same dimensions. Okay, by the way, first one seems to be incorrect because momentum is just mass into velocity, isn't it? Momentum is mass into velocity. Velocity you can write just as c into c square, and here it is mass square. It means it is not satisfying. Incorrect. Okay, second one, here mass square, here just mass. Incorrect. Third one, mass square. Okay, here also mass square. In energy also you will get mass square. Okay, that is correct. And now check for the c to the powers and then you match here. Okay, so momentum is mass into velocity. You can write just as mass into c square. So square into c square. So you are getting mass square velocity to the power 4. You are having here mass square into velocity to the power 4. It means they are dimensionally equal. Yes, they are dimensionally equal. It means this, you know, mass to the power, here I am getting mass to the power 2, here also it should be mass to the power 2, here also it should be mass to the power 2. Here I am getting velocity to the power 4, here is also velocity to the power 4, here also will be velocity to the power 4, isn't it? Like if you take the formula of kinetic energy, half mv square, whole square, when you do, velocity to the power 4 will become there. Okay, it is matching. So this is correct. Fourth one is incorrect. Now these relations may not be numerically correct. Okay, may not be numerically correct, but dimensionally they are correct. We are able to apply principle of homogeneity in third equation. Therefore this equation comes out to be correct. Now next question. Here also let us check which formula is dimensionally correct. Applying the principle of homogeneity, determine which one is correct. T is time period, G is gravitational constant, M is mass, R is radius. For gravitational constant you can use this formula. Force is equals to G into mass square divided by R square. Use this formula and put here and then check which relation satisfy dimension of left side is equal to dimension of right side. 4 pi square, they are dimensionless. 4 and pi square, they are dimensions. You can remove 4 and pi square. Other constants, you put the dimensions, check on the left side, check on the right side. If they satisfies the condition of principle of homogeneity, you will say that is correct, otherwise that is incorrect. So give it a try from your side. Take 1 minute. Okay, take a minute, give it a try. Give. Okay, let us see here. One way is, I can try to relate that way using the formula. Okay, let us do that way only. So G is same as force into r square by mass square dimensionally. Okay, and let us go one by one. Okay, in the first formula, T square equal to dimensionally, I'm just removing 4 pi square because that is dimensionless. Just r divided by mass square into what is G, force into r square by mass square. This mass square is getting cancelled. This r is getting cancelled. Is it possible that these two can have same dimensions? No. In force, I am having unit kg meter per second square. In time, it is just second. It means this relation is incorrect. First relation is incorrect, not possible. Okay. Now go to the second one. Is it possible? No. Here it is second square. Here it is meter cube. This relation is also incorrect. Now go to relation 3. Okay. Let us put things here. Go to relation 3. Put things there. T square dimensionally 4 pi square I am removing, r cube divided by G into m. G is my F, r square by m square, okay, into the mass m. This mass is getting cancelled. Okay, this r square will get cancelled. Here I am getting this as r into mass divided by f. Now write the units. Okay, what is the unit of r? Length, that is meter. For m, kg divided by, for force, that is kg meter per second square. So kg meter per second square will go in the numerator, just second square. T square time square, same, it is matching. Yes, it is matching, so third one is correct. Oh, you need break? Okay. Then next application is conversion of unit, and here we are taking a 15-minute break. Let us get back at 7:30. Not 7:30. Let us take okay, let us get back at 7:30. 10-minute break. So we are back, students. Next application of dimensional analysis is unit conversion. As we were discussing that any physical quantity you denote, as took an example of mass 10 kg, you may take an example of a length. Let us take 5 meter. Here this is numerical value. This is the unit of the that. Okay. Now I can write this as 500 centimeter also. I converted the unit from meter to centimeter. When I converted the unit from meter to centimeter, the unit is getting smaller. The numerical value is getting bigger. So the combination of numerical value and unit, that is a constant. Let us take, you are denoting that physical quantity first in first system of unit. The numerical value is N1 there and the unit is U1. In the second system of unit, the numerical value is N2. The system of unit is U2. So N1 U1 is equal to N2 U2. First system, second system, numerical value. Here the second numerical value, first unit, second unit. Now in a question like they will give in the second system of unit, what will be the numerical value? You can use this relation. Like if you want to find N2, N2 will be equals to N1 U1 divided by U2. That way, I'll show you actually how I'm talking about. Okay. So same way here, 5 meter that converted to 5 centimeter. Okay. Unit is decreasing, numerical value was increasing, the product is the same. Now see the example. Okay. A density of a material in SI unit is 128 kg per meter cube. Okay. Then in a certain unit in which the unit of length is 25 centimeter, unit of mass is 50 gram, the numerical value will be. Now here what we are changing? Here we are changing the system of unit. I defined some hypothetical system of unit where length unit is 25 meter, means 25 centimeter length I am taking as 1 unit of that. Okay. 50 gram mass I am taking as 1 unit of mass. In that new system, what will be the numerical value? Okay. So write that. I will say numerical value in the first system of unit into the first system of unit is equal to numerical value into second system of unit into second system of unit. Okay. What is first system of unit numerical value? 128. What is the unit? Kg per meter cube. Okay. What is the numerical value in second system of unit? I have to find that. What is the second system of unit? What is the second system of unit? Okay. So density is mass by volume. I'll write second system of unit. First understand this. Density is mass by volume. Density is mass by volume. Now in second system of unit, my mass is some, you can say unit is 50 grams by the way. Okay. So that I am writing as, let us take my kg dash. Kg dash you can write, or you can write that as, let me write that way only. Okay. So that is my kg dash and meter dash. That way. New unit kg dash. Okay. Here new unit I am taking meter dash. New system of unit. Okay. Okay. Now see, what is kg dash? Here system of unit is 50 gram. Mass is 50 gram. Meter dash. Here my length is 25, unit is 25 centimeter. So that is 25 centimeter. That thing, and 128 kg per meter cube. Now from here you have to solve to find what is the value of N2. Okay. So guys, this is kg, this is gram. You have to convert both into grams, then only they will cancel. This is meter, this is centimeter. Both you have to convert either in meter or both in centimeter, then only they will get cancelled. Okay. So first let us convert. So 128 into kg, I am converting that to grams. So I can write that as 1000 grams. Yes. Divided by 1000 grams. Divided by meter cube. Let us convert meter into centimeter. So when you convert centimeter, it will become 100 centimeter. 100 cube. So that will become 100. I'm just writing 100 into 100 into 100 to simplify that, because a few things will get cancelled. Therefore, I'm writing it like this, is equal to N2 into 50 grams divided by 25 cube into centimeter cube. Now you see, this gram, this gram, this centimeter cube, they are getting cancelled. And this 1000, okay, I cancelled 1000 also. Then this is 25 into 25 into 25. So you can take you can write this as 25 into 25 into 25, this 25 into 2, this 25 into 4. Okay, what else? This 25 is there, this 2 is there. Those things I can take on the left. Okay, so my N2 will come out to be 128 by 4, and this 25 will come in the numerator there. 25, yeah, I think this 10 was also there, na? Yeah, 40 it was. 25 divided by 2, yeah. Then 5 into 5, 5 into 8, 8 into 16, 16 into 8, okay. Then 5 into 8 is 40. Some calculations were there. But the rule is numerical value into the system of unit, that is constant. Okay, so here there was hypothetical system of unit. Sometimes like they will ask you how you can convert 1 Newton into dyne. Dyne is CGS system of unit, the unit of force. Okay, so in Newton, that is kg meter per second square. In CGS, that is gram. Okay, like for force in SI system is kg meter per second square. Okay, in CGS system that will be gram centimeter per second square. Okay, so then you have to accordingly find the two relations. So that you can do. Just you have to do N1 U1 is equal to N2 U2. Then derivation of relation between given physical quantities. This is an important, very important application, I'll say. Okay, let us take, you know that one physical quantity is depending upon these three physical quantities. Maybe you can say, let us take some physical quantity A. Okay, what should I take? For some physical quantity X depends upon three physical quantities A, B, C. Okay, A to the power A, you can say alpha, beta, gamma. Let us take alpha, beta, gamma. That relation you know. Then you need to find what is alpha, what is beta, what is gamma. What you need to do? Put the dimensions on both sides. Dimensions on left hand side has to be equal to dimensions of right hand side. Then you will write the equations, okay, relating the power of MLT. You will solve for alpha, solve for beta, solve for gamma. That way. I'll show you with examples. Let us take this example. If force, velocity and time are considered as fundamental physical quantities, then dimensional formula of density will be. Okay, let us take, I know that density is equal to mass by volume. That we know. That I know. But I cannot express density in mass and volume, because here these three are taken as fundamental. You should not write like this. Okay. Then I will say, let us take density depends upon force to the power A, velocity to the power B, and time to the power C. Okay, then both sides you write the dimensions. Let us write the dimensions of density. What is density? Density is mass by volume. So the unit is kg per meter cube. Okay, so the dimensions are ml minus 3. Okay, ml minus 3. Put it ml minus 3 to the power A. Sorry, this is on the left side, ml minus 3. On the right side, this is force. What is the dimensions of force? mlt minus 2. Okay, so you can put mlt minus 2 to the power A. Velocity is meter per second, so lt minus 1 to the power B. Time is just t to the power C. On both sides, equate the power of m, l and t. You will be able to solve for what is a, b and c. And then you will get your relation, how density is related to these three physical quantities which they consider to be fundamental here. Okay, let us do it quickly. Here m. Okay, so here first of all equating the powers of m. What is the power of m here? 1. So 1 is equal to, what is the power of m here? A. Here it's not there. I got a is equals to 1. Okay, then let us equate power of l. L power is minus 3 equal to, what is power of l here? L to the power a. Okay, here b, so plus b. Here it's not there. A plus b is equals to minus 3. A is 1, so I got b as minus 4. Clear? Then equate the power of t. What is power of t on the left? 0. Okay, what is the power of t on the right? This is minus 2a, minus 2a. Okay, here minus b, minus b. Here it is c, so plus c. Clear? Then put the values of a and b which you got from first equation and second equation. 0 is equal to, a is 1, so minus 2, minus b, b is minus 4, so minus 4, plus c. From here, what is my c? C I got as 2. Okay, c as minus 2, sorry. C comes out to be minus 2 because this is minus 2 plus 4, this will become plus 2 whole, c comes out to be minus 2. So I got the relation that it comes out to be f to the power a is 1, so 1, velocity to the power b, b is minus 4, so minus 4, time to the power c, c is minus 2, so minus 2. So f1 v minus 4 t minus 2, second option is coming. So that way you can relate. Okay, for every, yeah, we will have one shots here on this channel. Okay, for all the chapters we will be covering the backlogs. Next, if surface tension, moment of inertia, Planck's constants were taken as the fundamental, the dimensional formula of linear momentum will be. Okay, so you consider linear momentum depends upon these three. Okay, surface tension, okay, s to the power a, moment of inertia, I to the power b, Planck's constant, h to the power c. I took this relation, equate that, both side put the units, sorry, put the dimensions both side. P is momentum, momentum is kg, mass into velocity. Okay, so kg meter per second, m l t minus 1. Surface tension is force by length. Okay, so that is kg, like force by length I am taking. This is my surface tension. So force unit is kg meter per second square divided by meter. So this is kg per second square, m t minus 2 to the power a. Then moment of inertia. Moment of inertia I is my mass into the distance square. So that is kg meter square. So m l2 to the power b. Then h is Planck's constant. I know energy is equals to h into the frequency. This formula you will learn in 12th. Okay, don't worry about that. H into frequency. Frequency you can write as 1 by time. So h dimension is same as E into the time. Energy into time. What is the unit of energy? Kg meter square per second square. Into time, when you will do, the second to the power will become 1. So put the dimension m L2 t minus 1, this to the power c. Then both sides equate the powers of MLT, solve for ABC, you will get which one is correct. Okay, now I am leaving the calculations for you guys, you can do that after the class. Similar question, another similar question. Frequency of oscillation of a drop of radius r depends upon these three things. Okay, write the relation is already given. Write the dimensions both side, solve for ABC. Okay, so this is homework for you guys. You have to find dimensions. I'm giving you the formulas here. Okay, so coefficient of viscosity I took, gave you formula, force is equal to 6 pi r eta v, Planck's constant, energy is equals to the Planck's constant h into frequency. Frequency you can write as 1 by time, and then you can solve. Thermal conductivity, power is equals to Ka into delta T by delta X. That relation, K is the thermal conductivity. Okay. Boltzmann constant you can write as power is equals to sigma into A T to the power 4. This relation where sigma is the Boltzmann constant, and then you can like write what is the relation that comes for sigma, then you can write what will be the like answer here. Getting it that way? Okay, so you want me to solve? I can solve also. Coefficient of viscosity we have not done, let us do that for coefficient of viscosity. So force is equals to 6 pi r eta into v. From here 6 pi is a constant, you can remove that. Eta is just force divided by r into v. So force unit will be kg meter per second square divided by r is meter, velocity is meter per second. That way you write the units and then you will be able to write. Okay, then you will be able to write what is the dimensions of eta. Now Boltzmann constant, okay, there are Stephen Boltzmann constant and Boltzmann constant. I think this here we have to take the other Boltzmann constant that is there in the thermodynamics. So that relation you can take as PV is equals to NKT. Okay, NKT, where K is my Boltzmann constant. So that Boltzmann constant which I took was the Stephen Boltzmann constant. So they are not given here because that will come out to be Kelvin to the power minus 4 and all. That is not needed here. So here K is my Boltzmann constant. That relation you can use, and accordingly you have to write the dimensions of all the four. Next. Okay guys, we have learnt dimensional analysis, but there are some limitations of dimensional analysis also. Okay, what are the limitations? First, it supplies no information about dimensionless constant. Like you got this relation as density is equals to like let us take any relation here. That relation you can take. Momentum is equal. There can be some constant also here. There can be some constant here. So the thing is, it will not provide you information about the dimensionless constant. You can derive some formula using this. Okay, it will give you the empirical relation, but it will not tell about the constants. Like if I say that the kinetic energy depend upon mass and velocity, find the formula. You will get kinetic energy dimensionally equal to mass into velocity square. It will not tell you that there has to be a half, because what is the dimension of half? Dimensionless. You cannot get the dimensions dimensionless constant using that. Okay. Then the relation has to be product type. What if there is plus something like that, sine of something is there, cos of something is there, all those will not be there, isn't it? So that is also half, you can say half knowledge that you are getting here. It does not predict numerical correctness of the formula. Yes, the final thing, that a formula which is dimensionally correct, that may not be physically correct. Like if I give you the same example, like if I give you kinetic energy is equals to 1 by 5 into mv square. If I ask you, is this dimensionally correct? You will say yes, it is dimensionally correct. But is this correct? No, it is not correct, because it has to be 2 here instead of 5. So a formula which is dimensionally correct may not be physically correct. But if something is dimensionally incorrect, physically it has to be incorrect. Okay guys, now we are moving to the next part, that is errors. Till now we talk about units, we talk about dimensions, we talk about dimensional what we say, the dimensional formulas, dimensional analysis, those things we discussed. Now let us talk about errors. When you are measuring something, let us take, you are doing an experiment to measure the value of acceleration due to gravity, finding the value of g. So which experiment you will do? Simple pendulum experiment we will do. Okay, there we have like time period is equals to 2 pi root L by g formula we know. Okay, so we have the pendulum. Okay, we will swing the pendulum, we'll measure the time in how much time it is doing, how many oscillations, we will put in this formula, we know the length, and then we will find the value of g. These type of things we'll do. So whenever you will measure anything, there will always be some errors. Okay, there will always be errors. Getting it? Like I'm saying, let us take if I ask you what is the length here, measure this length, you may say okay, if I have to measure this length, I will take a scale. So I'll put a scale here. Scale will have some numberings 1 2 3 4 5 6, maybe like this in centimeters. This length is coming till here. You will take, okay, this mark is matching here. Okay, you will measure till here, you will say this is the length. But is that correct? No, it is still proceeding further. So I am saying, then what is the limitation? That limitation is there in the scale, it should have further marking. But still there will be small error always when you measure it. So error will be there. Which types of error can be there? So basically now let us talk about what is the error. Error is the difference between the real value and the value which you are measuring. Okay, so this is, I'll say, difference. Let me write, error is basically equal to the difference between the true value and the measured value that you are measuring. True value and the measured value. Now when I'm generally talking about, I'm just talking about the difference. Now if you take about care about sign also, then it can be positive, it can be negative, depending upon how your measured value. If your measured value is more, we call that as positive error. Okay, negative error when it is less. Okay, it depends upon whether the true value is more or true value is less. But here I am talking just about the difference of the two. Okay, just about the difference of the true value is not equal to measured value, there is some difference, that difference we are calling as error. Positive, negative, I'll talk about in a while. Okay, we'll talk about in a while. So what type of errors are there? Basically, if I categorize all the types of error, there are two types of error. One is systematic errors, another is the random errors. Like any instrument, if you talk about, let us take, you are having a weighing machine, or you are having a scale, or you are having a thermometer to measure the temperature. Okay, these are all are measuring instruments. So any measuring instruments which you are having, okay, when you are taking the measurement with that, there can be two types of error. First is the systematic error, second is the random error. Systematic error means those which you know the reason of that. Okay, first it can be some instrumental error, there is some error in instrument itself. You are having a weighing machine, okay, which when nothing is there on the pen, it is still showing maybe 50 grams or 20 grams. So there is some error in that, okay, isn't it? So there is some error in the instrument. Some environmental error, yes, you are trying to measure, let us take some mass in a weighing pan, but there is very strong fan on the top which is pushing the pen down, and it is showing some incorrect values, isn't it? Environmental error. Then observational error, there in the way you are taking the observations, in that there is some error, like you know, you are measuring the time with a stopwatch, you are starting it, you are stopping it. Can you stop that exactly, you know, 100% precision? Can you stop that with that? No, not possible. So there will be some observational error. Personal error, the way you are taking the observation, like some person while taking the observation of a let us take of a weighing machine, you are putting your hand also slightly, but you are putting hand, due to which some difference is coming, 100 grams or you know 50 grams. So there will always be some errors. Second type of errors random error. These are systematic errors, okay, which you can see and you can improve. You can work upon them and you can improve. But there are some random factors which you don't know what happened, but those errors are there. You cannot avoid them. You can avoid these errors. You can have a better instrument. Yes, you can avoid. You can, let us take the fan was there, you switched off the fan. Okay, the way you are taking observation, you change that and you know, reach some better precision. You can, personal error also, you told that guy, okay, don't put that hand while measuring that. You improve that. But there will always be some random errors. Like, you know, you are doing some experiment where, you know, frequency of voltage, you know, the source which is coming is needed particular frequency, and generally the particular frequency, there is hardly any change in the particular frequency, but all of a sudden in one of the readings there was a slightly more fluctuation in the frequency, due to which the error came in the final reading. It may happen. Like I did so many experiments measuring the torque, you can say, of a DC motor, okay, and you know, there are so many factors due to which some error will come in that. Now some factors are certainly which you know, but some factors are completely random. You cannot predict what happened exactly at that time. The fluctuation in the voltage happened, which is very rare, but it happened that day, and due to which the error is there. So some random errors whose cause you don't know can be there. Now yes, these things I have explained. Okay, now when you mention the reading, let us take, when you mention the reading or the measured value, reading means the measured value. When you mention the measured value, you, let us take, you are measuring with a scale. Okay, I asked you measure this length. What you did, you brought a scale, you brought a scale like this. You are putting the scale here. The scale is having some marking 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so it was ahead of 11, but you can say before 12. So this is 11 and you told this is 11 centimeter. Okay, you are saying this is 11 centimeter. In this we say that this last digit is my uncertain digit. Like you cannot be sure about this digit. This can be tending to 12 also. This can be, you know, just before 11 also, still you are marking 11th. So we say that this last is my uncertain digit. And let us take, you are measuring some another length and you told the length comes out to be maybe 159.63 centimeter. You are having a better scale and you measured this way. In this reading also, these readings you will be sure, but this last digit is uncertain. This can be tending to 4 or it can be tending to, you can say, 2 also. Some difference I'm saying. This last digit we always call that as the uncertain digit. Okay, so when we mention any measured value, we mention that with proper representation which shows the significant number of that reading, which will give you an idea about certainty and uncertainty. Like let us take, you are measuring some length with a scale which is having 1 meter precision and you got the length to be 100 meter. You will not say, you will just not mention 100 meter. You will say that comes out to be 100.0 meter. You will say this is my uncertain part, that is my certain part. That way I'm saying, like, you know, the measured value tells you about the certain part and uncertain part. Okay, so how we see the certain part and uncertain part? The last is always uncertain, before the last they are certain. So any measured value, we measure the number of significant digits in the measured value. These significant figures is the combination of the certain plus 1. The certain number of digits plus 1, that we call as the number of significant figures in that measurement. Okay, so there are some rules of number of significant figures. I'll tell you the rules, but I'll not write the rules. I'll give you an example, from there you can learn. Let us take a number is like this. How many significant figures are there? If 0 is not there, all the digits are significant. You will say here 1, 2, 3, 4, 5, 6. 6 significant digits. If 0 is not there, all the digits are significant. Only the confusion is with 0. Okay, only the confusion is there with 0. Without 0, all the digits are significant. Now, with 0, okay, if a number is like 2003, it will have 4 significant figures. If the 0 is between non-zeros, it will be significant. It will be significant. Okay, if the number is 2000, then it will have just 1 significant figures. These zeros are not significant. The trailing zeros are not significant. Okay, if the number is, let us take 0056, then these zeros are also not significant. Only 2 significant figures. Okay, if it is 2000.0, then it was 2000. Here it was only 1 significant. This is significant. These are not significant. But in this, because the decimal is there, these 3 are significant and this is also significant. Here I will say we are having 5 significant figures because of the decimal place. If the decimal place is there, that will be significant. Okay, but what about this 00.056? 0. Let us take, how many significant figures are there? Only 3. After decimal, you have to, like, when zeros are there, always count the zeros which are right of the first non-zero. Which are right of the first non-zero. Right of the first non-zero. This is significant, this is significant, this is significant. This 0 is significant, but this is not significant, this is not significant, this is not significant. But here, yes, these zeros were right of the significant, but the decimal was not there. Therefore, these are not significant. So here we are having 3 significant figures. Just I am telling you how to remember the rules, just with some examples. Okay. Now, if there is some scientific notation means 1.0 into 1.03 into 10 to the power minus 15. These type of representations we call as the scientific notation. If that thing is there, so this into 10 to the power something is not significant thing. Okay, so just you have to count the significant digits in the first part. How many significant digits are there? 1, 2, 3. So I'll just say these are here. There are 3 significant figures. That's all. So these are the rules which you can remember with these examples. Clear? Okay, guys. Next question is find the number of significant figures in this. Can you do? Like first, second, 3, 4th, 5th. Okay, so just apply the rules which we just discussed till here. This is 2.84. All non-zeros are there. All non-zeros are there. It means this is significant, this is significant, this is significant. Here I am having 3 significant figures. Okay, here this is not significant, this is not significant because this is before first non-zero. This is significant, this is significant. This is 2 significant figures. Here, not, this, and this, 4 significant figures. Okay, here, this is scientific notation. So, remove, forget about this, just see significant figures here. Here, I am having 2 significant figures. In this, forget about this. Here, we are having 1, 2, and 3. So, here we are having 3 significant figures. Easy. And yes, significant figure questions are asked. Significant figures questions are asked in mains, in advance also, like calculations of significant figure. I'll tell about that. Okay, so but you have to remember the rules. If rules are, okay, questions are very easy. Actually, students get confused whether this zero is significant or not, whether that zero is significant or not, and then they make mistakes. Otherwise, significant figure questions, yes, not always they are asked, but yes, significant figure questions are asked, and they are the most easiest question in the entire paper. Okay, guys. Now here's some matrix match thing. These zeros are between two non-zeros. These all are significant. 4. So I got second. In this, 1, 2, 3. 3 significant figures. 3 significant figures. So which one is first one? Here. 1, 2, 3, 4, 5, 6. These zeros are also significant, okay? After the decimal places. So 3 plus 3, 6. Fourth. In this, these are not significant. 1, 2, 3, 4, 5. 5 is third. Okay, so 2, 1, 4 and 3. 2, 1, 4 and 3. Third option is matching here. Clear? Now, rounding off rule. So rounding off rule you all know, but quick revision for you people. Let us take, if a number is like 23.57. Okay, if I ask you round this off to 3 decimal place, okay, round off to 3 significant figures. If I ask you like this, you have to round off till 3 significant figures. 3 significant figures means you have to drop the last one. You have to drop this. If you have to drop this, what is the rule says? What the rule says? If this is greater than 5, it is 7, increase this by 1. So increase this by 1, it means this will become 3.6. Okay, because this was greater than, this is greater than 5. Okay, what if this is 3.53? You have to round off, then just remove it. Okay, don't increase this time. Okay, it will just become 23.5. okay, what if it is 3.55, and if you ask to round off, then what it will happen? What will happen in this particular case? Okay, now it is 5. If it is 5, you check the previous one. If it is odd, increase by 1. If it is even, leave it as it is. Okay, so previous one in this way. If odd, increase by 1. Is this odd or not? Yes, it is odd. It is odd. Therefore, increase by 1, 23.6. If it is even means, let us take an example of 23.45, and you have to round off from here. Is this even, the previous one? This is 5, yes. Is this even? Yes, this is even. If this is even, leave it as it is. This will become 23.4. So these are the rules of rounding off, covered with examples. Okay, I hope you got it. The confusion is with 5. These things are very clear, like greater than 5, it will increase. Okay, less than 5, leave that as it is, drop it. Okay, confusion is with 5. Confusion is with 5. When this one is 5, okay, when this one is 5, whether to increase and decrease, you have to check whether the previous one is odd or even. If odd, increase by 1. If even, leave it as it is. Okay, now the rules of calculations with significant figures. Okay, let us talk about first addition and subtraction. So let us take, you have to add or subtract 2 digits. What is the rule of significant figure says? So the rule of significant figure says, when you have to add, let us take 12.56 and 3.1. You have to add these. Okay, So first, the rule says the final answer should contain the least number of decimal places. How many decimal places are there? 2. How many decimal places are here? 1. So final answer will contain only 1 decimal place. Okay. So rule of plus minus says the final, I should say right here. Okay. For plus minus, final answer should contain least number of decimal places among the two. Okay, so you will say, sir, shall we drop it? No, don't drop directly. You have to round off. First add them. What it is? You will say this is 6. Okay, this is 6. This is 5. 1 here. So I got this number. Now it is having 2 decimal place. I should only have 1 decimal place. Therefore, I have to round it off, the last digit. Okay, now round off. Don't drop, round off. This is 6. Is it greater than 5? Yes, it is greater than 5. So when you will round it off, it will become 15.7. So 15.7 will be your answer, not 15.6. Okay, not 15.6. 15.7 will be your answer in this case. Then this was for addition and subtraction. Now I am talking about multiplication and division. Multiplication and division. Now multiplication and division rule says we check total number of significant. We don't check after the decimal. We check total number of significant figures. So here this rule says the final answer should contain least number of significant figures among the two. Don't get confused. For plus minus, after the decimal place, least number of digits after the decimal place. Here, least number of total significant figures. Least number of total significant figures. Let us take, if I ask you multiply 12.03 into 156. Okay, multiply these two. So what will be the answer? Okay, so first what you have to do, so you will say, okay, let us do the multiplication. Just let me use calculator. First of all, we will do multiplication. What is the answer? 12.03 into 156. So the answer comes out to be 1876.68. This is the answer. Okay. Now the rule says, how many significant figures are here? 4 significant figures. How many significant figures are here? 3 significant figures. So the rule says this should contain 3 significant figures. Now it should contain 3 significant figures. It means, let me write here, it should contain 3 significant figures. Least among the two, 3. So it means from where you have to draw, where you have to round off? From here. Okay, this is 6. Is this greater than or less than 5? Greater than 5. If it is greater than 5, increase the previous one, 188. So I will say 188 is the answer. This is not the answer. This is the answer according to rules of significant figures. Okay, guys. So in the options you will see this also. Okay, so don't mark this. This is the answer according to rules of significant figures. And we have seen in JEE Advanced also these type of questions asked. You have to find a plus b. So just first add them. This is 3, 6, 1, 3. Then after decimal place, it should have only one place, because here 1, here 3, only one place. So you have to round off from here. Is this less than 5? Yes. So drop it. The answer is 3.6. This is the answer. 1.5 by 1.5. What is the answer? You are dividing. How many significant figures here? 2 significant figures. How many significant figures here? 2 significant figures. So the final answer should contain the least among the two. So 2 significant figures should be there in the final answer. How many significant figure? 1. Incorrect. How many? 2. Correct. How many? 3. How many? 4. So just check the number of significant figures. Just check the number of significant figures. This is the question asked in JEE Mains. Now this some multiplication is given. Some multiplication is coming given here. Okay. Now you may say, sir, do we need to do the calculation? No, don't do the calculation in this. Just check the number of significant figures. Here, how many? 3 significant figures. Here, 4 significant figures. Here, 3 significant figures. So the final answer should contain only 3 significant figures. How many here? 5. Wrong. How many here? 3 significant figures. Correct. I think previous one I did one thing when I was rounding off. Okay. One thing is there. This I just wrote 188. Zeros should be there. You cannot write just 188. You cannot round off 1876 to write just as 188. That was wrong, sorry, from my side. When you have to round it off, you have to put a 0 there. You have to put a 0 there. It was 1800 figure, na? So that order has to be same. Okay, so you have to put a 0 here. This 0 will not change the number of significant figures, but yes, that 0 has to be there. Sorry for this mistake. You can correct it now. Okay, here, coming back here. Here, how many significant figures? 3 significant. This is correct. How many? 4 plus 3, 7. Incorrect. How many? 4 plus 2, 6. Incorrect. So just you have to match the number of significant figures. That's all. Okay, let us do this question now. Time period of oscillation of simple pendulum. 4 readings are taken like this. What we need to find? Arithmetic mean of these readings in correct significant figures. So you take the mean first and then convert that to, then apply the rule of significant figure. Okay, so first take the mean. This is 4.62 plus 4.632 plus 4.6 plus 4.64. Divide that with 4. Divide that with. First add them, divide with 4, write the final answer, then round it off to convert it into the required form. Because here 2 decimal place, 3 decimal place, 1 decimal place, 2 decimal place. Final answer should contain only 1 decimal place. Here only 1 decimal place I need. You can see in the options also only 1 decimal place you need. So third is the correct answer. But let us do the calculations also from my side. This is 4.62 plus 4.632 plus 4.6 plus 4.64. So what it is? This is 18.492 divided by 4. Okay, divide that with 4. This is 4.623. Now first write this, then you apply the rule. Okay, first do all the calculation, then apply the rule. Now the rule says it should contain only 1 decimal place. I have to round it off from here. Less than 5? Yes, less than 5. Drop it. You got the answer 4.6, which is third option. I hope you all are able to get. Okay, next question. Okay, these questions you can do as part of your homework. Just apply the rules which I was discussing. This is also a part of your homework. Order of magnitude. What is the order of magnitude of any numerical value which is written like, you know, some a into 10 to the power x, like that? So you have to convert a between 0.5 and 5. Then whatever power you are getting here, that is the order of magnitude. Let us take, you are having some numerical value as 560 into 10 to the power 3. Now somebody asks you, find the order of the magnitude. So first of all, you will convert this in between 0.5 and 5. Okay, so if you write it 5.60 into 10 to the power 5, yes, it will become 10 to the power 5 like this. Yes. Is it less than 5? Not less than 5. It has to be less than 5. Okay, then I will write it 0.56 into 10 to the power 6. Is it between 0.5 and 5? Yes, it is between 0.5 and 5. Now, what is the power? Power is 6. So, I will say the order is 6. Okay, the order is 6. Don't say the order is 5 from here, because this should be less than 5. Less than 5. Convert into less than 5, greater than, you know, 0.5, in that range, comes in that range, then write the order. Okay, so these prefix, you know, 10 to the power 3 is there, that we say kilo, 6 is mega, 9 is giga, 12 is tera, and these also, you know, 10 to the power minus 3 is milli, minus 6 is micro, minus 9 is nano, minus 12 is pico, femto. These orders you can have a look, because these things are many times mentioned in the question. Then you have to convert that to SI. Okay, so you need to have a knowledge of this. Like sometime they will give the power to be this much megawatt, so you need to know how much is mega. Okay, now representation of error. You are doing an experiment to find the you can say you are measuring one, you can say one measured value. Let us take, you are finding x. You did experiment 5 times. You got first time x1, second time you got x2, third time you got x3, fourth time you got x4, fifth time you got x5. These are your readings. You will say, sir, if we will do experiment 5 times, we will get 5 different values. Most of the times, means almost every time you will get a different reading. Like whenever you will do experiment in lab na, although you are keeping all the things same, the readings will change a bit. There are so many reasons, random errors and other errors. Okay, so many type of errors are there. So the readings will not be same. If you will do 10 times, you will get 10 different values. Let us take, you are finding the value of G. Sometimes you will get 9.6, 9.5, 9.4, maybe 9.8, 9.9 or 10 or maybe 10.1, like that. You will keep on getting different values, because there are, you know, always, you know, some error in noting the time, some error in length. When you combined, final value will be having some error. Okay, so let us say you are measuring a value, and these 5 times you did the experiment, you got the 5 values. Now we define the true value as the mean of these. If you know the true value, we take that as true value, but if you don't know, we take the true value as the mean of these values, x1 plus x2 plus x3 plus x4 plus x5, divide by 5, take the mean. That is my true value. Okay, so I got my true value now, and this true value I denote with x bar, the mean of that. Okay, then find the absolute errors in each of the reading. Absolute errors. What I'm doing, why I'm doing these things, by the way, like I'm getting 5 different values. What I will say my experiment gave me, like, or my measurement is, what should I say? Should I just mention the true value, just the average of that? That is also incomplete knowledge, because I need to tell now how much error is there in that. So I'm finding the error part basically. Now absolute errors, find the absolute error in each of the one. So delta x1, mean minus the first reading, delta x2, mod of mean minus the second reading delta x3, mod of mean minus the third reading delta x4, mean minus the fourth reading delta x5, mean minus the fifth reading. Okay, these are my absolute errors. Then find the mean absolute error, take the mean of that. Okay, then find the mean absolute error. Mean absolute error, you can denote that with delta x bar. Take the mean of these x1 delta x1 plus delta x2 plus delta x3 plus delta x4 plus delta x5 divided by 5. Now when I will mention my reading, I will say my value, okay, my measurement is the mean value plus minus delta x mean. This is how I will show my measurement. This is how I will show my measurement. This is my measurement. Here in this is my true value, this is my error part. This is my error part, this is my true value. Okay, and if somebody asks you from here, what is the relative error? What is the relative error? Okay, you'll take the error part divided by the true value. Okay, this is my relative error. If somebody asks you what is the percentage error, take the percentage of this. So percentage error will be multiply this with 100. It will be converted into percentage. So this is how we denote, we give. Now here we are giving complete information. Okay, here I am telling you how much is my measurement and how much can be the error in that. So complete information I am giving in this. Let us do this question here. Okay, let us do. So I did successively, I measured the length, I got these values. Okay, I have to find the mean length, the mean absolute error and the percentage error. Let us do it quickly. So mean first, the true value. This we call as the mean value also. Okay, what that will be, just add all of them, divide with 5. 5.14 plus 5.10 plus 5.11 plus 5.13 divide with 5. Okay, so how much is that? Let us do it quickly. 5.12 plus 5.14 plus 5.10 plus 5.13, okay, plus 5.11 also, 5.11 divide with 5, and I got this as 5.12. I got this as 5.12. So this is my true value. Now you have to find the individual absolute errors. Okay, so absolute errors delta x1 will be mod of true value 5.12 minus the first reading, that is 5.12 only, 5.12. Next is my delta x2, okay, then delta x3, then delta x4, then delta x5. Okay, take the mod of that with each and every digit. Okay, accordingly I'll write this as 5.12 minus 5.14, here 5.12 minus 5.10, here 5.12 minus 5.11, here 5.12 minus 5.13. Okay, and then you have to find the mean of that. Let me do it. 5.14, just a second. Okay, So this comes out to be 0.00, this comes out to be 0.02, this is 0.02, this is 0.01, this is 0.01. So these are my individual absolute errors. Then you have to take the mean absolute error. So 0.00 plus 0.02 plus 0.02 plus 0.01 plus 0.01 divide by 5. Yes, there are some calculations in this question, but questions are asked, therefore I am covering here. Okay, now 2 plus 2 4 plus 2 6, 0.06 divided by 5, that comes out to be 0.012. But the rule says it should have two decimal places. It should have two decimal places, 0.01. Okay, so I got the absolute error. The mean absolute error is 0.01. Then find the relative error and percentage error. Percentage error also you have to find. Okay, delta x divided by x into 100. That will be my percentage error. What is delta x bar? 0.01. 0.01 divided by, what is the true value? 5.12. 5.12 into 100. This is my percentage error. I'll say this much is my error. I hope you are getting it. So how much it is? 0.01, that comes out to be, just a second, 100 divided by, sorry, 1 divided by 5.12. So this comes out to be 0.19. 0.19%. So this is our answer. This much is the percentage error in this quantity. So these steps you have to learn. Okay, do one, you can do 3-4 questions at least from any of the standard book. You'll learn these steps quickly. This is a JEE advanced question. Okay, so here you have to do the same things. You have to do the same things. I brought it so that you can solve this from your side. So take this as a part of your homework, and we have covered this. We had covered this in our session. Okay, so now you can do this as a part of your homework. Now, combination of error. You are having 2 or 3 measured value. Now these measured values are having some errors. Now you are adding them, subtracting them, dividing them, multiplying them, or taking some power. Now you are getting some another your value which you want to find. So that will also be having error. How much error will that be there in that? So that we need to find. Okay, so first of all, let us talk about addition or subtraction. It's the same thing, actually, the same way it goes, but I'll cover them separately for you people. So to avoid any confusion, I'll cover them separately. Let us talk about addition first. Okay, let us take my physical quantity z depends upon a and b as a plus b. A is also having some error, that is a plus minus delta a. B is also having some error, b plus minus delta b. Delta b means error in b, delta a means error in a. Now a and b are having some error. You are finding z, which is a plus b. How much error will there be in z? How much error will be there in z? Okay, so I am finding z. So I will say that my z, that is z plus minus delta z, is equals to a, that is a plus minus delta a, plus b, which is b plus minus delta b. Z is a plus b, z is a plus b. So my error part in z plus minus of that is equals to plus minus error part in a plus minus error part in b. I got this relation. It can be plus, it can be minus, so many combinations are there. You can take this as plus, this as minus, this as minus, this as plus, both as minus, so many combinations are there, isn't it? But I need to find how much is the maximum possible error in this case. So the maximal possible error will be delta a plus delta b. So error in z, the maximum error in z, that is delta a plus. Whenever we talk about error, actually we talk about always the maximum possible error. Hello, hello, hello. You want to say something? You can mention here. Somebody is saying hello, sir. Hello. Grace. Okay, so this is for addition. Same way for subtraction also it will go. Subtraction, here it will become minus, but the rule will remain the same now. When you have to find the maximum possible error, it will just become a plus b. Let us see. So subtraction, my z depends upon a and b like this. So when you say z as z plus minus delta z, it will be a plus minus delta a minus b plus minus delta b. So we got this relation. I know z is a minus b. My z is a minus b. Z is a minus b. So this is getting cancelled. Now I am getting the relation between delta z, delta a, delta b, and to find the maximum possible value of that comes out to be delta a plus delta b only. Okay, maximum possible, whether you are subtracting or whether you are adding, the error part will always add, because you have to find the maximum possible. Okay, then multiplication. Multiplication part, let us take my z is equal to a into b. A is a plus minus delta b, b is b plus minus delta b. I need to find how much error will be there in z. There are two ways. One is you go by simple method, or another is you just differentiate and find the relation between the error parts. Sir, you won all the hearts and left us when we needed you the most. No, actually, I'm not the one who left you people. So it's the management decision. I mentioned you all. Okay, so accordingly, I have to move. So it's not my decision. Okay, guys. So I hope you understand that. Now, you need to find the error in Z. How the error in Z will depend on error in A and error in B. Okay, so let us differentiate it. Now I think you all know how to do differentiation and integration. Let us differentiate it to find the error parts. Can I differentiate it? Yes. With respect to whom? Let us differentiate with respect to Z. Okay. dz by dz is equals to d by dz of a into b, like this. If it now here you have to apply product rule. First take a out, differentiate b, then take b out, differentiate a. So it will be a db by dz plus b da by dz. Okay, okay. Now see it. See here carefully. Here it is a dB by dz, here it is b dB by dz, here this is dz by dz. Dz differentiation of z with respect to z is 1 only. So this is 1 is equal to a into dB by dz. Dz I can take on the left side. So a dB plus b dA. Okay, and here my dz came by differentiating. Okay, divide with z both side. Divide with z both side. Okay, can I write this z as AB? Yes, z is equals to AB. You can write this as AB. Then I got as dz by z is equals to dA by A. Okay, when you divide this, B will get cancelled. dA by A plus here when you divide AA will get cancelled. dB by B. dz is error in z, dA error in A, dB error in B. So when you write the error relationship, delta z by z is equal to delta A by A plus delta B by B. So this is the derivation. Yeah, goodbye guys. So this is multiplication thing. Now let us talk about division also. Can we do the same derivation? Yes, you can do the same derivation. Okay, I think you should try from your side. You will get the same relation actually. But let us do division. Z depends upon A and B as A by B. Now you differentiate it. So certainly here differentiating will be a bit difficult because that will not be easy. 1 by b, so that will become minus 1 by b square, and accordingly then you have to do it. We'll take some more steps. Instead of differentiating directly, let us take log and then differentiate. Log of z is equal to log of a minus log of b. Yes. Now differentiate with respect to whom? With respect to z. Differentiation of log z with respect to z is 1 by z. Okay. The differentiation of log a with respect to z will be 1 by a into dA by dz, chain rule. Similarly, 1 by b into dB by dz, chain rule. Dz you can take on the left. Dz by z is equals to dA by a minus dB by... Now you will say, sir, we are getting minus sign. Although you are getting minus sign, but we have to find maximum possible error. So when you have to find maximum possible error, you will take only the positive sign here. So it will become delta z by z is equals to delta a by a plus delta b by b. When you have to take the maximum possible error, the plus sign will remain only. Clear? Okay. Now, some questions on that. Let us try to do them. Yeah, I'm also missing you guys. A silver wire has mass this, radius this, and length this. The maximum percentage error in the measurement of density will be. Okay, one more thing, sorry. I forgot about product and power thing. Huh? If some power is there, okay, let us take z is equals to a to the power n. How that error will relate now? Okay, so here you are multiplying a into a n times. So delta a by a, delta a by a, delta a by a will come n times. So I can say delta z by z is equal to n times delta a by a. If the power thing is there, like this, you write. Okay, now if power is not there, let us take but some combination is there, power and some other variables are also there. Let us take my z is equals to a to the power alpha, b to the power beta by c to the power gamma. Let us take if this kind of relation is there. Okay, so power of a is alpha, so alpha times delta a by a will come. Power of b is beta, so beta times of delta a by a will come. Power of c is minus gamma because it is in the denominator, na? But minus will not come there, it will come plus only because I need to find the maximum possible error. Therefore, always take the plus sign. So I will write delta z by z as alpha delta a by a plus beta delta b by b plus gamma delta c by c. Okay, I am not writing minus here. Please pay attention because I need to write the maximum possible error here. Okay. This is how we are writing that. Now let us do this question. A silver wire has mass this, radius this, and length this. The maximum percentage error in the measurement of its density will be. So density is equal to mass by volume. We know this formula. Okay. Now mass, what is the formula for volume? You can say pi r square L. Wire is a cylinder, na? So you can write like this. Now density is depending upon mass, radius and length. The powers are given. Now if I write delta rho by rho, that will be equal to delta m by m plus 2 delta r by r plus delta L by L. Now multiply both sides with 100 to find the percentage error. This equation will give me the percentage error. Now I'm not writing minus sign here. Please pay attention again because I have to mention always the maximum possible error. That is the reason. Okay, now put the values. What is delta m? This is my delta m. This is my m. This is my r. This is delta r. Delta r. This is L. This is delta L. Now put the values. 0.6, sorry, 0.006, 0.006 divided by 0.6, 0.6 plus 2 into delta R 0.005, 0.005 divided by 0.5 plus delta L 0.04 divided by 4 into 100. Now you see how much percentage error you are getting. Okay, you multiply 100 inside. Okay, so 0.06 and 0.06 into, when you will do 100, it will just become 0.06, it will get cancelled. Okay, similarly this will get cancelled. Similarly this was 0.005, yeah, similarly this will get cancelled, and you'll get 1 plus 2 plus 1, that comes out to be 4%. So the answer comes out to be the first option. Okay, got it. Next, a physical quantity Q depends upon ABCD like this. Okay, then the percentage error in Q is, we'll relate the same formula. Okay, like the same way, delta Q by Q is equal to delta A by A, okay, plus 4 delta B by B, okay, plus delta C by C plus delta D by D. Then multiply both sides with 100 to convert everything into percentage. Now you can put the values and you will get whatever it is asked in the question. That will be easy for you people. Okay, now another question is there. This question was asked in JEE Mains 2024. Let us try this. Okay, to find the spring constant K of spring experimentally, a student commits 2% positive error in measurement of time. Okay, now again here, when positive and negative errors specifically are mentioned, then you have to take the sign positive and negative. Okay, otherwise we always take positive signs. I was talking about the in error, just take the positive because we have to find the maximum. But if specifically the positive error and negative error is mentioned, then you have to take the sign properly. Okay, to find the spring constant K of a spring experimentally, a student commit 2% positive error in measurement of time. Okay, so delta T by T into 100 is plus 2%. 1% negative error in measurement of mass, delta M by M into 100 is minus 1%. The percentage error in determining the value of K. So here the formula that is there, which is 2 pi root M by K. This formula is there, which we are using. You can derive this formula also. 2 pi is not needed. You can derive this formula by using the dimensional analysis. Okay, how the time period will depend upon mass and the K. You can derive that. Okay, so now if I write the error in T, how the error in T depends upon error on M and error on K, that relation I need. Okay, so use this expression and write. So I will say from this expression T is equal to 2 pi root M by K. I will say delta T by T is equal to, power is 1 by 2. So 1 by 2 delta M by M. Okay, sorry, I have to find the value of K. So first write relation for K. From here, if I write relation for K, that will come out to be 4 pi square M by T square. First of all, write relation of K. I squared and wrote what is K there. Then you write delta K by K. So delta K by K is equals, 4 pi square is a constant, leave that. Delta M by M, okay, minus 2 delta T by T. Now you will say, sir, why minus? Why not always plus? I have to write minus because I have to consider the sign of the error also. Then if you have to take the sign properly, you have to take this time to the power minus 2 with minus sign only. Then multiply both sides with 100. Now delta m by m into 100 is -1. Delta m by m into 100 is -1. Delta t by t into 100 is 2. Okay. So delta t by t into 100 is 2. 2 into 2 is 4. Minus sign is there, so -4. So I got final answer as -5%. He just wants the magnitude, so 5. Fourth answer is coming here. So that way we have to write. Okay. It's not 4%, it's 5%. Aryan. Next question. If the percentage error in measuring the length and the diameter of a wire are this, okay, the percentage error in measuring its resistance will be, how resistance is related? Rho L by A. Write area in terms of diameter because the question they are talking about diameter. So resistance is equal to rho L by area, you can write as pi d square by 4. Now resistivity is rho, that is constant. Pi by 4 is a constant. Okay. I am having error only in length and diameter. That's all. Length and diameter. So when you write delta R by R, that will be equal to delta L by L plus 2 delta D by D. You need percentage error, multiply both sides with 100. Multiply both sides with 100. Like this. So delta L by L into 100, what is that? Percentage error in L? 0.1%. 0.1% plus 2 into delta D by D into 100. Delta D by D into 100 is also 0.1. So 2 into 0.1. So this comes out to be 0.3%. 0.3%, which is second option. Getting it? Now another question is there. Here P is depending upon A, B, C and D, and we have to find how much is the percentage error in the P. Okay, use this relation, right? Delta P by P will be equal to 2 delta A by A, okay, plus 3 delta B by B plus C to the power -1. I'll write +1 only, maximum error. Delta C by C plus D to the power -1 by 2. I'll write as 1 by 2 delta D by D. Multiply both sides with 100. 100, 100. Okay. Now you put the values. Delta A by A into 100 is percentage error in A, which is 1%. So this is 2 into 1% plus 3 into percentage error in B, 2%. 3 into 2% plus C, percentage error in C is 3%. 3% plus 1 by 2 into percentage error in D, that is 4%. 4%. So I got this as 2 plus 6 plus 3 plus 2. How much it is? 13%. 13%. Okay. First option. Getting it? Yes. Another question here. This is a good question, by the way. Let us do it. In a simple pendulum experiment, for determining the value of acceleration due to gravity, time taken for 20 oscillations is measured by using stopwatch of 1 second least count. Now 1 second least count means the error that can be there in time is of 1 second. This is my delta t. 1 second is my delta t. This is my delta t. Just a second. Yes, this is my delta t. Then the mean value of time taken comes out to be 30 seconds. Okay, 30 seconds. The length of pendulum measured by using a meter scale of least count 1 mm is obtained to be this. This is my length. Okay, and this is my possible error in the length, maximum possible, which is my delta L. Then the percentage error in determination of G is close to. Now this simple pendulum experiment, we use this formula. Okay, we use this formula for this. You don't know this formula, but I'm telling you this formula, you can use this. Sir, not understanding. Sir, not understanding. Okay, what is the doubt you can mention now? If you are not understanding, you can mention your doubt. I'll take that doubt. Don't worry. Just mention. Now, using this formula, I have to find the percentage error in G using this formula. Okay, using this formula, if I write the G relation, so G will be equal to 4 pi square that L by T square, it will come out to be like this. So I will say delta G by G is equal to 4 pi square is a constant, delta L by L plus 2 delta T by T. This relation I got. Now here I have to put delta L, delta T, T. Okay, what is delta L? 1 mm. 1 divided by. What is L? 55 centimeter. Convert that to mm also. Mm only, because this is in mm, you can convert this also in mm. 550 mm. 550 mm. Okay, plus 2 into. What is delta T? Delta T is 1 second. 1 second. 1 divided by. What is T? T is 30 second. 30. Multiply both sides with 100. You are getting the percentage error in G. Okay. Now we are using this formula. You don't know this formula. If you have to derive, again I am saying you can use the dimensional analysis, which will give you the relation T depends upon root L by G. That way. Otherwise, in when you will do simple harmonic motion, okay, there you will do the derivation of this. So anyways, you will learn this in oscillation chapter. I hope the calculations you can do from here. Clear? If you are not understanding, if you are having any doubt, you can mention. I'll take that doubt. Okay, please mention where you are stuck, at which point you are stuck. I'll take that. Otherwise, I'm using the same formula. Na? I'm using the same formula again and again. This is the formula. This is the relation. From here, we discussed how to write the relation delta G by G is equal to delta L by L plus 2 delta T by T. That's all. Then just I'm reading the question, I'm telling this is delta T, this is my T, this is my delta L, and this is my L. Just put the values and I got the answer. Okay. If doubt is there, you can mention. Previous question, sir, third step. Okay. Previous question, third step. Here I am just putting the values like delta A by A into 100 is percentage error in A, which is 1%. So this is 2 into 1% error in A. 3 into percentage error in B is 2%. So 2%, 3 into 2%. Delta C by C into 100 is percentage error in C, 3%. Okay. 1 by 2 delta D by D into 100 is percentage error in D. That is 4%. Just I am putting that. From this relation, I am writing like coefficient, power of A is 2, so 2 delta A by A. Power of B is 3, 3 delta B by B. Power of C is minus 1, but I'll take plus 1 because maximum. So plus 1 into delta C by C. Power of D is minus 1 by 2, so 1 by 2 into delta D by D. Okay, I hope you got it. And here this is there, you need to find the error in Z. Again, this relation is given. So delta Z by Z is equal to power of A is 2. So 2 delta A by A. Power of X is 3. So 3 delta X by X. Power of Y is 1 by 2. So 1 by 2 delta Y by Y. You want percentage error. So multiply with 100. Multiply with 100. Now one important thing here is this. A is a constant. If A is a constant, delta A will be 0. Change in A will be 0. This is 0. Because A is a constant, this is 0. Delta X by X into 100 is 4. Error in X. Okay. Delta Y by Y into 100 is 12. Error in Y. That is 12%. Put the values, you'll get the answer. Error questions are very easy to do. Like very easily you can do them. Okay. So no complex things are there in the error parts. Clear? This is a good question. Two resistances are given. R1 is there, R2 is there. Find the error measurement in the equivalent resistance when they are connected in parallel. Parallel, when you connect them, then 1 by R equivalent is equals to 1 by R1 plus 1 by R2. You all know this formula from class 10th. Now the thing is, Prajit Vikram, We know this formula of finding the equivalent resistance when they are connected in parallel, but this is not in power, this is not multiplication also, division also directly. So directly you cannot write the error relationship here. When you get some relation which is among none of the relations which we learned, it's not addition, not subtraction, not multiplication simple, not power, or not power of something and multiplication division, no, it's some different relation. If some different relation is there, then you do differentiation and then you know, find the error relationship first. Do differentiation, okay, with respect to whom? You can differentiate it with respect to R parallel itself, okay. So 1 by R parallel, I am differentiating that with respect to R parallel. 1 by R1, I am differentiating that with respect to R parallel. I will divide and multiply with the dr1 here, okay. drp was there, I multiply and divide with the dr1 to differentiate, because with respect to rp I cannot differentiate r1, I need r1 only, so I multiply and divide with dr1. Chain rule it is, you all know, it is just chain rule. So d of, similarly with r2, multiply and divide with dr2. Okay, we got it like this. Then differentiation of 1 by rp minus 1 by rp square. Simple. Differentiation of 1 by r1 minus 1 by r1 square. dr1 by drp. Similarly, minus 1 by r2 square. dr2 by drp. Now it is easy. drp you can take on the left. Minus minus you can cancel. All will become plus. So drp by rp square is equals to dr1 by r1 square plus dr2 by r2 square. What is drp? Delta r parallel. dr1 delta r1, dr2 delta r2. You can put them delta r parallel, delta r1, delta r2. Now you can do calculations. Yes, you got the relation. Now just you have to put the values and do the calculations. First, you can find r parallel by using this relation. You can put r parallel here. Okay, r1 delta r1, you know, this is my r1, this is my delta r1, this is my r2, this is my delta r2. Now put the values and do the calculations. Okay guys, so this we have covered in units and measurements till error portion. So we are ending this live here. You will get these notes, so we are ending this live here. You can revise them again, you can solve these questions by your side, so the fundamentals will become firm. Yes, few things I have covered in, you can say, a bit greater speed in my sessions which I took in Arjuna JEE in English. I have taken each and everything in great detail there. I have covered this in 10 lectures. Each lecture is more than 1.5 hour duration, so there all the details are there. So if you want all the details, go there, watch. Number of questions are also more in that. Okay, here I have just, you know, quickly went through with the questions with all the topics. Okay guys, thank you all. Bye bye.